Okay, hello everyone. I welcomes to all in our lecture series on superconductivity. In this lecture series, we are going to discuss these topics, which are most essential for B.sc, B.Tech, M.sc, M.Tech, and various entrance examinations. In our last 4 classes, we have been discussed these topics. In today's class, we are going to discuss critical magnetic field represented by Hc and corresponding important questions. Okay, so let us start. This is the introduction part we discussed. This is the Meissner's effect. Here you can see superconductor in superconducting state expels the magnetic flux, which is called the Meissner's effect. In detail, we have been discussed. Then how susceptibility is -1 or diamagnetic, perfect diamagnetism at the superconductor of a superconductor in superconducting state, that we have been discussed. London's equation we discussed in detail. Then we discussed variation of London penetration depth, corresponding numerical also we discussed. In this class, we are going to discuss this one, critical magnetic field. Okay, or if we increase the magnetic field strength, then what about Meissner's effect? In our previous classes, we discussed, suppose this is a superconductor which is at T less than Tc or in superconducting state. Then if we are going to apply magnetic field, then it will expel the magnetic field like this. This is your Meissner's effect. Okay, okay. Now at this stage, if I increase the strength, applied magnetic field strength, if I increase, then what is going to happen? It is found that if the applied magnetic field strength will increase after a certain magnetic field strength, here if we increase the magnetic field strength, then after a characteristic magnetic field strength, the Meissner's effect will be completely disappeared. That means after that characteristic magnetic field, the expelled magnetic fluxes will enter inside the superconductor like this. That means it transit to superconducting state to normal state. Superconducting state to normal state when H will greater than equal to Hc. Okay, so here Hc is called as your critical magnetic field, that is represented by Hc, what we discussed. So above a characteristic magnetic field, the Meissner's effect disappeared. That magnetic field called as the critical magnetic field. This much you have to write for 1 mark question in your exam, right? From various experimental results, it has been found that Hc at any arbitrary temperature, that temperature in between Tc and 0 Kelvin, it is related like this. Sc naught, here Sc naught means magnetic field strength at 0 Kelvin. Sc naught into 1 minus T by Tc. Here T is any arbitrary temperature between 0 Kelvin to Tc. If I am going to follow this mathematical equation and I am going to draw the graph, then we can found this graph. At 0 Kelvin, if I will put T equal to 0 over here, then Sc will be H naught. At T equal to Tc, if I will put T equal to Tc over here, then this value will be 1. So 1 minus 1, 0. So Sc naught, Sc will be 0. So at 0 Kelvin, this critical magnetic field strength is maximum. This is the maximum value. At Tc, Hc value is minimum and the minimum value is 0. So I suggest you just remember this expression, which is very, very important for different type of numericals. Now we are going to go for 2 important questions based upon this expression. Okay, here is the first question. The transition temperature of a superconductor is 8.2 Kelvin. Suppose transition temperature, it has been given. This is the transition temperature Tc equal to 8.2 Kelvin given. it loses its superconducting property if the magnetic field this much at 5 Kelvin. That means this is suppose 5 Kelvin, the critical magnetic field how much given 4.3 into 10 to the power 4 ampere per meter. Okay, so we have to find out what is the critical magnetic field at 0 Kelvin. See here, interestingly, the language is this one. It loses its superconducting property if the magnetic field strength is this one. That means indirectly it is written that SC equal to this much at 5 Kelvin. Okay, so these are the data given in the question. We have to find out the critical magnetic field at 0 Kelvin. We know this expression, all the data has been given. TC given 8.2, having SC equal to how much 4.3 in 10 to the 4 ampere per meter at 5 Kelvin. Transition temperature given this one, and critical magnetic field at 5 Kelvin is given this one. We have to just substitute these values. So here SC at 5 Kelvin, we have to put over data over here, and T already given 5 Kelvin, TC given, and we have to find out H naught. Simple question. Here I just written that SC equal this much, so H naught will be written this much. So just substitute these values. SC T this one, T value is 5, TC value is 8.2, and just solve this mathematics. You can find this much ampere per meter, 6.84 10 to the 4 ampere per meter. Consider next question. For a given specimen, the critical magnetic fields are given as this much, 1.4 10 to the 5 and 4.2 10 to the 5 ampere per meter for 14 Kelvin and 13 Kelvin respectively. Calculate transition temperature and critical field at 0 Kelvin. TC and H naught we have to find out. Right? Expression we know this one. If I am going to consider this value for this temperature, then this expression will be how much? Like this. 1 point this one 1.4 in 10 to the 5 H naught 1 minus here T will be 14 Kelvin, this much, equation number 1. Like that, if I consider this data which have temperature 13 Kelvin, so equation number 2 we can found, just divide equation number 1 and 2, just divide, we can found this one. After solving this equation, we can found TC equal to 14.474 Kelvin. Here TC we found. Then we have to find out H naught. Any one equation you just consider, either equation number 1 and equation number 2. Consider equation number 1. 1.4 into 10 to the power 5 equal to H naught 1 minus 14 by TC we found 14.474 square. Okay, you just solve this expression and you can found H naught value in ampere per meter unit. You just do by yourself. Do by yourself. This question is very important question. You can found in your exam 4 to 5 mark. This is a 4 to 5 mark question. Very simple question. Just practice and prepare for exam. Okay. So okay, here we have to stop our today's class. Next class we are going to discuss Sills B effect. Okay. Thank you so much for watching this video. Thank you.